All right. So welcome to the SCAP 2020 and the presentation of our paper, Automated Environmental Impact Assessment via Asset Administration Shell. So we, that are Anva and I, will give you a short overview of our paper. So my name is Lara Waltersman, and I'm working in the research field of sustainable production at Fraunhofer IPA.
And my name is Anwar Al-Asadi. I'm working at Fraunhofer IPA as well. I'm working there for 2 years. My scientific focus is on robotics.
All right. So thank you, Anwar. And so first of all, I will give a short introduction of our paper, and then I will go on with the state of the art of the environmental impact assessment and as well of the asset administration shell. And then Anwar will take over with implementation, results, discussion, and our outlook. So first of all, our introduction. So yeah, why did we write this paper? So we see an increasing requirements for companies regarding climate neutrality and as well environmental impact as in general. So there's more legislation, for example, in CSR reporting and more public awareness, especially due to Fridays for Future. And as you can see here with the newspaper articles, many companies also already set their own goals, for example, for climate neutrality. Therefore, we have the environmental impact assessment, which is becoming more and more important, but the data acquisition for these assessments still costs a considerable effort here. This is the reason why we had to look into the asset administration shell as as a technology for an easier data acquisition and transfer. And thus, we hope that it enables a more detailed and real-time capable accountability for environmental impact of products and services. So our research question of this paper is, how can the asset administration shell be used for environmental impact assessments? So in order to answer this question, we have the state of the art first. So here you can see what is the environmental impact assessment. It's an assessment of the impact of a planned activity on the environment. It's used within companies for internal decision making, for sustainability reports, or also for CO2 labeling of products. It's the most common method actually is the life cycle assessment, and there currently exist many software solutions, but they usually do not allow the real-time monitoring, and most of all, there is a manual data acquisition needed. So on the other side, the technology we assessed was the asset administration shell. This is a standardized digital representation of the asset. It holds digital models or different digital models of various aspects. They are called submodels. It describes the technical functionality, and it can be derived from the approach of an Industry 4.0 component. Here on the left side, you see the RAMI 4.0 model, which is the basis for an Industry 4.0 component. So also different approaches and implementations have been shown in different literature. Here you can find them in our reference literature in the end. As we saw that to date, no asset administration shell has been used for an environmental impact assessment, and thus no submodel was specifically derived for an environmental impact assessment. Further, we also looked into the features of an asset administration shell and then looked, okay, what advantages and which applications can be derived from these features. So an asset administration shell has standardized interfaces, semantic knowledge representation formalism, and it's real-time capable. So here you can see the advantages for an environmental impact assessment. You have an automated data acquisition, which has a considerable less effort than the used methods today. You can have an interoperability of assets. You have an enhanced data availability and validity, and you have there's an enabled data processing and aggregation. Especially aggregation is pretty important for environmental impact assessment. And then we thought and we looked into the literature, what are possible applications within a company. So these are this list, for example, environment-oriented production planning, real-time accounting of environmental impacts, etc. You can look them also up in our paper. And we have inter-company applications. So this means between different enterprises. And here, especially the data exchange is pretty important because the data exchange can be used to fulfill regulations, to identify industrial symbioses, and also to have environmental impact assessments of products for along the entire value chain, and also for the whole life cycle of a product. So for the use phase, and also for the end of life phase, for the production phase, and so on. And last, the improvement of circular economy, because you have a higher data availability, for example, of the use phase. All right, so Anwar, now it's your turn.
Thank you, Lara, for the introduction. I will take over and give you an overview about the implementation results discussion and then short outlook. The first thing is what we implemented already is the side of the let's say the equipment, the manufacturing equipment. On the one side we have a robot, which is a lightweight robot here at Arena 36, and the other part contains the energy logger, which is an PLE 103, and on the other side virtual asset administration shell for the calculation of energy and calculation of the CO2 emissions. The first thing is what I'm gonna just give it very short. The asset administration shell of the robot contains motions and product-related properties, such as start of the program and the end of the program. When does the program start? When does it end? And on the other side, we have on the same time and the energy logger, where the current and the voltage, including also the power which is resulting from the current and voltage, is published to a central system, which is an MQTT broker. We are working here at Arena 2036 with the approach of the asset administration shell in different equipment and different manufacturing assets, and all our informations are getting summarized in MQTT broker. On the other side, you have something like an asset administration shell for the product, which is currently not implemented, but it's on the way there. On the next slide, I will present you very small our results. On the left side of the slide, you can see the power curve over the time during the production of two different products. You can see there is a constant state or a steady state where the power is constant because of the constant controller consumption of the robot. And on the other side, if you overlap that with the information when the start and the end of the product program, which is published by the robot, you can see where it started and ended. So you can do a separation between the products. On the in the first part, you see product A. On the right side, where the number 3 is highlighted, is product B, and you can do the accounting and the allocation of the both. Now I just plotted the carbon dioxide emissions in cumulative variant, and you can see there is a difference between the period where it's using a product and the robot, and where the robot is not producing something, because the slope is different, and here you have a decreasing of the slope. Here the slope is higher, and the results are presenting the data transparency and usage of overlapping data allows us to do a specific accounting for products and do CO2 labeling. A short discussion. We will discuss what we find out or what our technical side is limited, because we are just considering electric energy. So other media consumptions like cooling water or compressed air is not included in our approach currently. And we are just considering part of the assembly, which is the handling part. And another important fact is we are using the average electric CO2 consumption, which is 401 grams per kilowatt hour. Future implementations can include a specific power supply, like from renewable energies as well. On the other side, we have pretty theoretically derived point, which or questions which are still open, which data for the IAA acquired by the IIS could create value adding, for example, companies, societies, or authorities. On the other side, we have to create a semantically AA, because currently, as Lara said, it's not existing. And the resulting product should be described as well. What kind of services or business models are possible with the integration of AA in a framework of the asset administration shell. A short outlook, what we are doing here at Arena 2036. We are considering to use the pattern recognition via machine learning for the specific assembly task, to recognize which product is produced just only by the current curve, because it's obvious that we can see the difference between the specific products. Another aspect is we are going to substitute some manufacturing equipment here. We are going to use an Smart Pi, which is a pretty nice equipment. It's embedded with current and voltage measurement unit. And we are thinking about using the whole framework on or approach on a bigger robot. It's now, as I said, with a lightweight robot. On bigger robots, it should be more closer to the application side. And we are thinking about, as we said, our in the discussion, our approach currently is just picking up the handling part, but if you think further, and you should consider an entire assembly scope, like screwing, handling, or welding, as well as logistics. Feel free to ask us. There will be a virtual Q&A session. Just contact Lara or me. We will be happy to answer your questions. And now here, just a small overview of our references. Feel free to use that and cite it. Thank you very much. Lara, if you have something to add, just feel free to add that.
No, thank you very much. And yeah, we will see each other at the question and answer session, I hope.